Please don't forget to like, subscribe, and comment. Thank you so much.
Join us at Like Learning School and experience a transformative education journey. Visit our website at www.likelearningschool.com or contact us at +2348085095144 to learn more and get started today.
This is under connected rods on force and motion dynamics generally. The general principle we apply here is just F equal to ma. Okay?
Yeah.
You have this block 4 kg resting on this table, on this platform. Then there's a pulley and a string connecting this 4 kg with another block 3 kg. Now if this second block, which I can call B, is released, if B is released, you have to find the acceleration and the tension in the string. When you are doing this, you need to get the free body diagram. Free body diagram is just a way of getting the showing the forces that are acting. First of all, at B, what are the forces that are acting? Or can you identify one force that is acting at B?
Weight.
The weight acts downward, so we indicated weight. Let me use this to represent it. Weight acts downward, W. What should be the weight? We can just call it mg, or since the mass is 3 kg, if we are using g as 10 meter per second squared, so the weight will be mg. If you like, you can simplify as 3 times 10, is it not? That's 30 newton, right?
Yeah.
Okay, which other force is acting? Now, by the way, this represents what we call coefficient of friction. Coefficient of friction gives you an idea of the degree of roughness or smoothness of a surface. Sometimes when the question is modeled to be a smooth surface, if I want to hear smooth surface, ignore friction. In that case, it is assumed that there's no friction, but there's no such surface that you can't find a frictional force acting. It's just an assumption to simplify the analysis. Do you understand what I mean?
Yes.
Okay, so you hear words like smooth surface. You hear words like inextensible string. In other words, it doesn't stretch, so that you don't have to apply Hooke's law to complicate the analysis. So this is, in fact, most of the work you will get will be inextensible. It's not going to extend. And sometimes you would be told that it is smooth, so do not consider friction. But here, the coefficient of friction is given, so it is not a smooth surface. I mean, this surface is not smooth. This surface, this surface is not smooth. But the pulley is always assumed to be smooth, so you don't have to apply any other thing there. Now what do I mean? As this block B is being dragged down by weight, are you checking my illustration?
Yes.
If you drop block B is being dragged down by weight, it's going to be pulling block A along now, is it not?
Yeah.
If this is dragging down, if B is dragging down, it will pull block A along. So if block A is moving to the right, frictional force acts to the left. Frictional force always opposes motion. So it acts in the opposite direction to motion.
Right. Yeah.
So you need to also represent the frictional force. Let me use, what color can I use now? Let me use a black line to represent the frictional force. I said those forces should be represented to make it, to start with. So frictional force. Now frictional force is always equal to mu r, where r is the normal reaction. No,
Yes.
normal reaction, the reaction from the surface, the perpendicular reaction from the surface, the force from the surface that acts at 90 degrees to the surface. So I think I need to represent the normal reaction with a yellow line like this. By the way, what's the normal reaction? If the force is 4 kg, normal reaction will be 40 Newton without much ado, right?
Yes.
Normal reaction R is equal to, okay, let me write it here. Normal reaction R is equal to 40 Newton. So that you understand what I mean by normal reaction. This
Isn't that like the one that opposes it?
opposites weight, yes, opposites weight in a surface. For instance, the weight of this object.
Third law.
Pardon?
That's Newton's third law. Isn't it?
Yes, Newton's third law. For every action, there's an equal and opposite reaction. So let's even introduce that weight there. The weight acts downward. Let me represent it with the red. So these the body diagrams are necessary in resolving this. Weight acts downward. What's the value of the weight for block A?
40.
Okay, the weight for block A is 40 Newton too. If we're using G equal to 10, so it's just 4 times 10, 40 Newton. Normal reaction is 40 Newton. Frictional force is mu R, where mu stands for coefficient of friction, and mu is 0.05. Weight is dragging this one downward. The weight of B is 30 Newton. Now, there's still another force. This string, we have forces acting on it. If this, in fact, always represent the tensions going towards the pulley. Let me just give you a simple trick. The tension should be drawn to go towards the pulley, okay?
Yeah.
To be drawn to go towards the. So there's a tension force here. I'll call it T, if you like T1, and call this one T2. Since this string is not stretching, because this question is always modeled to be inextensible. Please, I'm mentioning this, you know those kind of questions, they will be giving you stories. Talk about why it shouldn't be this. Or if it is stretching, what implication will it have on the answer? Let me talk about it. You can get those kind of questions, all those 6 markers. How many markers do they normally call it?
6 markers.
All right. First of all, this string must not stretch. It must be assumed not to stretch, because if it stretches, you have to include Hooke's law. Hooke's law talks about force and extension.
Right.
Because F is equal to KE. Remember Hooke's law?
Yes.
So that's why we don't include a stretching one. Sometimes you will be asked, okay, why is it assumed not to stretch and all of that? So that we don't include the force due to stretching. All right. So it's inextensible, it doesn't stretch. And if that is the case, since it's not going to stretch, the tension here must be equal to the tension here so that it doesn't squash it. I mean, T2 must be equal to T1. It doesn't stretch, it doesn't get shorter. Can I say that again?
Yes, please.
If a force is acting this way, another one is acting this way, if it's not going to get shorter or longer, T2 has to be equal to T1. Okay?
Okay.
So those are ways to model it for simplicity. T2 must be equal to T1. T2 must be equal to T1. So we have the forces now. Once you have the forces, you are good to go. So the free body diagram is the first thing to do. All right, so that we can now start. We have to find the tension in the string and the acceleration when B is released. Again, you need to know which one is released. That I will give you a question on that to demonstrate what I'm talking about. Because the one that is released will also determine some things. I will give you a question on that. Okay, let's go. B is released. It's going to pull this down, dragging. B is going to go down, dragging A along. So let's look at B, for instance. B, at B. Are you ready?
Yeah.
All right, at B. At B. At B, what are the forces acting?
Weight.
Weight and
Tension.
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 And since it is going down, weight is going to be giving positive, tension negative. In fact, forces in the direction of motion is giving positive. Those in the opposite direction to the motion will be giving negative. Did you hear that?
Yes.
So which one will be positive?
Weight.
So at B, W weight minus T1 from Newton's second laws must give us resultant force, isn't it?
Yes.
Which is, please, this frictional force, how do I separate it from resultant force? Let me call it FR. So it doesn't look like the resultant force I'm talking about. Must be equal to resultant force, which is MA.
Yeah.
Okay. So considering forces at B, the weight going downward minus the tension going upward must be equal to the resultant force. And you know from Newton's second law, F is equal to MA.
Yeah.
Do you remember? In fact, F equal to MA is a major equation you use in dynamics. F equal to MA. F stands for what, by the way?
Mass.
F.
Oh, for resultant force.
Yes, please. F is always resultant force. So F is resultant force. You know, M is mass. Okay. All right. So W minus T1 is equal to F, which is MA. All right. Let's put in values.
Yeah.
Let's put in the values. W is 30, right?
Yeah.
I can still use the color I used. 30 minus T1 is equal to MA. And MA is what? What's M?
Mass.
Mass is 3, so 3A. We can call that equation 1. Let's consider B. At B, I will write this one in yellow, in red, in blue. At B, sorry, at A now. We are done with at A now. What are the forces acting?
Weight and friction.
Weight is acting this way,
Weight,
frictional
reaction.
force and normal reaction acting the other way. But in the direction of motion, because the motion is dragging it this way, the direction of motion, the only two forces that are important are
The friction and tension.
tension 2 and frictional force. So, and it is, which one will be positive? You know, remember this thing is being dragged to go this way. So which one will be positive? Which one will be negative?
You opened the
Which-
door to Melissa.
Which one will be positive? Which one will be negative?
The tension will be positive and the friction will be negative.
Okay, because it's going this way. T2 is positive, frictional force is negative. So at A, T2 minus frictional force will give us the resultant force, which is MA, right?
Yeah.
All right. So T2, let's substitute values, minus frictional force. Frictional force is mu R. Mu is 0.05. Normal reaction is 40. So 0.05 times 40, am I right?
Yeah.
40 times 0.05 is equal to MA, which is 4A. Let me know if you are still with me.
Yeah.
We call that equation 2. Equation 2.
How do you get 40?
No, that's mu r now. F, the frictional forces.
How is the friction 40?
No, frictional force is not 40. Frictional force is mu r. Mu times r. Normal reaction is 40.
Oh,
No.
R as in.
R is the coefficient of friction. R is the normal reaction. Mu is the coefficient of
Right.
friction. Is it clear now?
Yes.
Okay. Mu, coefficient of friction, R, normal reaction. So, and you told me, because we are only interested in forces in the direction of the motion. There's no motion vertically. I mean, at A, there's no motion vertically. Do you know? At A, there's no motion vertically. This is not jumping up, neither is it piercing through this piece. It's not jumping up, it's not piercing through this piece. So the only motion you have at A is the motion horizontally. Did you get me?
Yeah.
That's why we consider only T2 and frictional force. And T2 is in the direction of motion. So T2 minus frictional force is equal to the resultant force. T2 minus frictional force is equal to the resultant force, F, which is MA. So T2 minus frictional force is mu R. Mu R, 0.05 times 40. Okay. All right. So we have two equations we can solve. Remember, it's inextensible. T2 and T2 is equal to T1.
Yeah.
So we may as well forget about the T1s and all of that and just call T. So just solve these two equations. Equation 1 and equation 2. Okay, let me simplify equation 2 so that we can solve. Do you have your calculator there?
Yes.
Scientific, so that we can solve simultaneous equation.
So I should go to simultaneous equation.
Yes, 40 times
How
0.05.
many notes?
Yeah, 40 times 0.05 should give us 0. Should give us 4. No, should give us 2. Please let me check. 40 times 0.05 gives what?
2.
2, okay. Equation 2. So let's solve these two equations. This one, equation 1, and this one, equation 2. You know, in solving it, please, you need to arrange it properly. Did you hear me? Let me see. Can it be arranged properly? Yes. Are you listening?
Yeah.
If you're going to solve it with a calculator, it has to be arranged so that all the t's will be on the same column, all the a's the same column, constant the other way. Please, I think we need to arrange it so you can just solve with a calculator. Maybe we should write this. Let me write equation 1 as 3a plus t equals 30. Do you agree with me?
Yeah.
3a, t crosses over, then 30 will remain. So 3a plus t equal to 30. That's the adjusted form of equation 1. Then equation 2 should be, how should I write equation 2 so that all the a's on the same column? Give me a way to write
Equation
it.
2 will be negative 40a.
No, we can leave it there and just carry this
Okay.
across.
40a minus t is equals to negative 2.
40a minus t is equal to negative 2. That's equation 2. So let's solve these two instead.
Okay. So 3, 1 goes to 30.
Mm-hmm.
40 minus 1 goes to minus 2. X is equals to 28 over 43.
So that's A. X is the first one. A is equal to 28 over 43 meter per second squared. T is what?
And Y is equals to 1,206 over 43.
1,200 and
1,206 over 43.
over 43 Newton. Okay. That's one way to solve it, which is most examiners prefer. But you can treat this whole thing as a unit. In fact, I can recommend that. Treat this whole thing as a unit. That will help you to quickly get A. Treat this whole thing as a unit. Let me show you what I mean. All of them treated as a unit.
Yeah. Yeah, what do you mean a unit?
Like all of them, one part, one object, one body. Treated as one body. So you represent all the forces acting. Let me redraw it and show you what I mean. It will be good for you too because it helps to get this thing faster. Let me redraw it and show you. Show me the forces acting again. There is frictional force,
Tension.
which is mu r.
Weight,
There's tension.
reaction force.
One tension this way, the other one. Remember, this one is now is still A here and still B here. Okay, one tension is going this way, T1. Both of them are T's anyway, so there's no point differentiating. T, and then the weight, which I will represent here. So I'm treating all of them as one unit. It's the same thing I drew up here. Frictional force this way, tension this way, weight this way. I just put all in a straight line as a unit. Right?
Yes.
Alright, so that's an alternative method. Alternative method. Okay, so let's find the resultant force when treated as a unit. Remember, the mass of this one is 4 kg and the mass of this one is 3 kg. So what's the resultant force?
Right.
The direction of motion is to the right.
So the resultant force will be
Let's start. All the forces that are going to the right will be positive. The ones going to the left will be negative. Take note of this method because the motion is towards the right. So forces going to the right, positive. Forces going to the left, negative. So we have W is going to the right minus if I had differentiated these T's, if I call this one, okay, let me just call it T1 and then T2. Is that how I named it up there? Alright, that's correct. T1 and T2. So, okay, be giving me W. Which other one will be positive?
WT2
That's plus T2. All the negative ones minus T1 minus frictional force will give us resultant force F, which is MA. Treating all as a unit. So we can just substitute those values. You know T1 and T2 are the same, so they will cross out. So we're left with W minus this is equal to MA. What's W? W is 40, abi? Abi 30.
Yes.
Remember, this W is for mass B. This mass B, which is the weight is 30 newtons. So 30 minus frictional force. We found frictional force to be 2, right?
Yes.
It's equal to MA. Now this mass is the total mass because we are treating the whole thing as a unit. Did you get it?
Yeah.
I said the mass is what? This M we're using here, since we've taken all as one unit. This M in this equation is the total mass because it's a total unit.
Oh yeah. So the M will be
7. So 7A. Let's find A. So A will be what? So 7A is equal to 30 minus 2, that's 28. So A is what? Are you sure you didn't make a mistake in that first A you got?
That's what the calculator gave me.
Because A is giving me something reasonable. You sure you didn't make a mistake? When you do both, you get the same answer always.
3, 1, 30. 40, negative 1, 2, negative 2. Yo, but I didn't make a mistake.
You made a mistake.
Okay, named it.
3, 1, 30. Just otherwise you can just solve it. Then 40 minus 1 minus 2. I hope when I was arranging it I didn't make a mistake myself. 3A 3A plus T equal to 30. T minus 40A minus T. 40A minus T equal to this. Okay. Weight minus frictional force equals MA. 4 plus 3. 7A, get me A here, first of all.
That is 28 over 7, which is 4.
I am suspecting that something wasn't done right. They should give the same answer, whether treated as a unit or what. It should always give the same answer. Maybe this thing we're solving, we probably made a mistake somewhere. Okay. So when you get the A, you can just substitute. You now pick only one. I'm showing you this method. Now you pick only one at A, like I said at A now. Okay, let me complete this. We've gotten the acceleration 4 meters per second squared. When we're getting these funny numbers, I started suspecting something. But it's okay. We get to the root of the matter. Alright, so we've gotten this. In fact, anytime you want to get the acceleration quickly, treat all as a unit.
Okay.
It's weight, not 30. Or let me see the second equation. T2 minus frictional force. Oh my God. This is where we made a mistake. 4A and I wrote 40A.
Oh.
MA. I was supposed to write 4A and I wrote 40A.
Right. Okay.
They should always give the same thing. So this is actually 4A. Just correct 4A, please.
3, 1, 30.
And 4.
4 minus 1 minus 2. Yeah, x is equals to 4.
Okay, because the mass
Y
is 4.
equals to
So 4A, not 48.
Yeah, y is equals to 18.
Okay. So please let me correct this. 3 is equal, A is equal to 4, right?
Yeah,
Okay, 4 meters per second squared. Tension is what?
tension is
That's why.
18.
18, it makes sense. I don't know why those, okay, were the cost for those big values. Okay, so I said you can treat all as the same unit, you get the same answer. You can see 4 meters per second squared. Then what, if you want to get the other one, just pick only one section. Any section, especially the section with the smaller, fewer forces. I can say at B now and then finish up. At B, what are the forces? W minus T is equal to MA, right?
Yeah.
At B, you can, if you choose any way, you will get whatever you're looking for. Whether at B or at A, you will still get your T. So W is 30 minus T is equal to mass 3. We've already found A to be 4. So 3 times 4. Do you get it?
Yes.
Just substituting to get T. 3 times 4, which is 12. So 30 minus T is equal to 12. So T will be what?
T will be
30 minus T equal to 12. I think T is still 18 that we found earlier.
yeah.
Okay. So that's that. So this one says a stone A of mass 3m is attached to one end of a string. A small stone B of mass m attached to the other end of the string. Initially A is held at rest. So this A is held at rest on a fixed plane. The plane is inclined to the horizontal at an angle alpha, and tan alpha is 3/4. The string passes over pulley P, and that is fixed to the top of the plane. The part of the string from A to P is parallel to a line of greatest slope. Okay, those are just additional information. Stone B hangs freely from P as shown. Stone B hangs freely from P. Okay. Then we are told that the coefficient of friction between A and the plane is 1/6. The coefficient of friction A here at this point is 1/6. Okay. Stone A is released from rest and begins to move down the plane. This is important. This statement is important. It should be underlined. Did you see what I underlined? That's why I'm actually reading through all, to know how it is moving. Can you hear me?
Yes.
See what I underlined? Stone A is released from rest and begins to move down the plane. So it's actually stone A that is moving down the plane, not stone B. Stone B is not going down, it's A that is dragging down. Okay?
Okay.
So that we determine the direction of motion. So the direction of motion is actually this way. Let me zoom in to 200% since I have this now. So the direction of motion is down the plane. In what direction will frictional force act? In what direction will frictional force act?
Opposite.
Up the plane. So frictional force will act up the plane. We represent frictional force with this. Make it thicker. Frictional force will act like this. F frictional, which is mu r. And I told you tensions should be drawn to towards the pulley. So you have tensional force to the pulley, right? And also another tensional force to the pulley. They are the same, so you don't even need to differentiate, but I can just write T1 and T2 for when I'm referring to them. And of course, the weight of this of A acts this way, right? Vertically downwards.
Yeah.
It has a mass of 3m. Is that what we are told?
Yes.
A mass of 3m. So the weight will be what?
The weight will be 3mg.
Okay, 3mg. Please, it's good to leave it as g. 3mg. Since the mass is 3m, the weight will be 3mg. Can you see what I'm writing?
Yes.
Okay, so you need to represent the normal reaction. The normal reaction, how should it be represented? It must be at 90 degrees to the surface. Do you see what I drew?
Yeah.
90 degrees to the surface. This is a normal reaction. R normal, 90 degrees to the surface. Alright, I've done this with you before. I can't remember exactly, but I hope I have. If you bring this down a bit and complete this, you have resolved these two components. Okay, let me use the different colors. I've used the green. I will use the what can I use? Black. Why are we resolving it into two components? Because the motion is parallel to the plane. Can you see the motion parallel to the plane, right?
Yeah.
This weight is not in the axis of the motion. It needs to be resolved. Let me explain properly. Are you ready again?
Yes.
The normal reaction doesn't need to be resolved. This my normal reaction doesn't look like 90 degrees, so. But just I imagine this, what I drew is 90 degrees. I think it can be better. Should be able to draw a better line. This looks more like 90 degrees, Abby. So I have to redraw this. So this component will be like this now. Sorry, not so good. It's bending. It's bending. Okay, better. All right, so it's still bending, but it doesn't matter. All right, I wanted to show you. Are you listening?
Yeah.
This weight acting downwards is not in the direction of the motion. It's neither parallel to it nor perpendicular to it. The direction of the motion is parallel to the plane. Okay?
Yeah.
So this weight needs to be resolved into two components. The weight is not aligned to the plane of the motion. The plane of the motion is parallel to the plane. This thing I'm tracing, I hope it's showing at your end. Is it showing at your end what I'm using my laser to trace? Please confirm.
It is. I can see it.
Okay, so the weight is not in the direction of the motion. Neither is it perpendicular to it. So the weight needs to be resolved. You know, when you resolve forces, you split it into two, as it were. Give a component in the plane of the direct motion and another one perpendicular to it. So one component will be in the plane of the motion, this black one. The other component will be perpendicular to it, this green one. And they have to run in such a way that they meet the weight itself, which is the force we split, so to speak. So these green and black lines, are the components of this weight. And why did we split the weight? Because this weight is not in the direction of the motion we are considering, which is parallel to the plane. By the way, I don't know if I've done this with you. You probably might not remember. This angle here must be the alpha. This angle here must be this alpha by geometry. The angle here, is it showing? Must be alpha.
Yeah.
I said the angle here must be alpha. We'll do more of this. Let me just introduce this now. Okay, so if weight is 3 mg, what's the value of this place? Let me label it. What's the value of this place in terms of the weight? And what's the value of this one in terms of the weight? The green and the black. Give me those two components that we've resolved. The black is opposite to it. The green is adjacent to it. So the green, if you remember, your resolution will be 3 mg cos alpha.
Oh, yeah, cos another one.
While the black one will be 3 mg sin alpha, right?
Yeah.
3 mg sin alpha. All right. Which other force? I think we have all the forces now. By the way, normal reaction. Reaction normal. You know, this thing is not jumping up the plane. I mean, it's not lifted up the. It's not lifted away up. It's not lifted above the plane. Neither is it piercing into the plane. I'm talking about mass A. Did you hear me? Mass A is not lifted above the plane. Neither is it piercing into it. So the normal reaction must be equal to 3 mg cos alpha.
Right.
It's getting exciting. What I'm saying is there is no resultant force perpendicular to the plane. That's what I'm saying. The force normal reaction above the plane must be equal to the force 3 mg cos theta below the plane. The yellow force must be equal to the green force. Since it is not being lifted above the plane, neither is it piercing into, so the resultant force perpendicular to the plane is 0. All of that is to tell you that normal reaction must be equal to 3 mg cos theta. 3 mg cos alpha. Why? Resultant force in the vertical plane is 0, or no motion in the vertical plane. You can say no motion in vertical plane, or no motion perpendicular to the plane. No motion perpendicular to the plane.
Oh, it's so difficult.
Did you hear me?
Yeah, like it's kind of hard.
It's okay. You're equal to this now. What are you talking about? There's no motion perpendicular to the plane. The motion we have is parallel to the plane.
Right.
There's no motion going piercing into the plane or being lifted above the plane. So resultant force perpendicular to the plane is 0. In other words, this normal reaction in yellow must be equal to the one in the component of the weight in green. So normal reaction is 3 mg cos theta. All right. There's still something we need to do, because these things, like the angle is given as tan theta 3/4. So we need to get cos theta, sin theta. We have sin theta. Oh, sorry, sin alpha. We have sin alpha. We have cos alpha. So we need to get what they are, because tan alpha is given as 3/4. Except you want to get the angle, which is not always neat, because you'll be doing a lot of approximations. Okay, the story I'm just telling is this. Are you ready?
Yeah.
Tan alpha is 3/4. So what is cos alpha? Let me draw it here. See your trigonometry ratio. If this is alpha, tan alpha is opposite of adjacent, right?
Opposite of adjacent.
So this is 3, this is 4. Trigonometry, Pythagoras triple, here has to be 5, right?
Yes.
By Pythagoras triple, this place has to be 5. The hypotenuse has to be 5. So what is cos alpha? What's sin alpha? Therefore cos alpha will be what? What's cos alpha?
Adjacent
Of hypotenuse, which is 4 over 5. And tan alpha is what?
3 over 5.
Tan alpha is 3 over 5. I'm definitely sure we're going to do more work on this. So it's just an introduction, please. So don't give up, please. Sin alpha is 3 over 5. Let me write it in black. Instead of creating the angle and then doing all that, it's better to use it like this. Fractions are neater ways of resolving expressions like this. So sin alpha is 3 over 5, sorry. You write it. Sin alpha is 3 over 5. Remember, cos alpha is 4 over 5. Sin alpha is 3 over 5. Okay, so now our work begins. Frictional force. Frictional force. We are just drawing the free body diagram. By the way, frictional force is mu r, don't forget. Let me put it like this. Frictional force is mu r. Okay, so all of this is to show you something now. You see this force that is pulling it down. Are you listening to me?
Yeah.
You know it's going down the plane. It is actually this component of the weight. This one. That's the one that is dragging it down the plane. This component of the weight. So this force is 3 mg sin alpha. This force that is dragging it down is this component of the weight, 3 mg sin alpha. Because that's the only force that is dragging it down the plane. So this is 3 mg sin alpha. That's it, this one. 3 mg sin alpha is this force. When it is released, when this B is released, it drags, A goes down the plane. That means, you see why? We need to put this thing properly. I just saw something. T1 is not. I just saw something. No. That's what is right. We have not included the weight of this one. We are still in the right track. Weight of B. We didn't draw it. What's the weight of B?
Still B of mass M. So that's mg.
Mg. All right. So I told you to use the simpler one. Treat all as a unit. It's easier, so that you get something. What did they say we should find? What's the first question?
They said write down an equation of motion for A.
Right?
Write down an equation of motion.
Write an equation of motion for A. For A.
Yeah.
Where is A? An equation of motion for A, okay. Is here. So what are the forces in the direction of motion? What are the forces? In the direction of motion, what are the forces? Go ahead.
Weight.
No, weight is not in the direction of motion.
3 mg
sine alpha.
Alpha.
In the direction of motion, 3 mg sine alpha, frictional force, tension. These are the only three forces in the direction of motion. At A, did you hear me?
Yeah.
3 mg sine alpha is going in the direction of motion. I mean, parallel to the motion, let me put it properly. Parallel to the direction of motion. The three forces are 3 mg sine alpha, frictional force, and tension. And 3 mg sine alpha is in the direction of motion, so it will be positive. F, frictional force and tension will be negative. Okay, so let's write the equation. So it will be 3 mg sine alpha positive minus frictional force minus tension equals resultant force. Think about it.
That's so long.
7 marks. Is it not 7 marks?
It's 2 marks.
Oh, okay. Is this the B part that is 7 marks?
Yeah.
Okay, so you can imagine what B will be. Okay, but see, that B is not going to be difficult because you've gotten the rest. So I said 3 mg sine alpha minus, let me write it here so that I can use values. 3 mg sine alpha minus frictional force Fr minus tension T is equal to normal resultant force, which is Ma. Please confirm if you understood what I wrote.
Yes, I did.
All right. Okay, simply 3 mg sine alpha minus frictional force minus tension equals to resultant force, which is Ma, and the mass is 3m. So can we just simplify and then let's put values there. The coefficient of friction is given as 1 over 6. I think it's just the equation, so I don't know if we will have to. Okay, so 3 mg sine alpha. What's sine alpha?
Sine alpha is
3 over 4, right?
3 over 5.
3 over 5 minus frictional force is mu r. What's mu? Mu is 1 over 6.
Yeah, 1 over 6.
We're giving mu as 1 over 6. Where did I have that information?
Yeah.
Okay, yeah. Coefficient of friction is 1 over 6. And frictional force is mu r, which is 1 over 6 for mu times the normal reaction, 3 mg cos alpha. Okay. All of that are not required, though. I'm just so that we'll do the other one.
Yeah.
3 mg, 3 over 4 minus frictional force mu r. Mu is 1 over 6. 1 over 6. Yeah. R is 3 mg cos alpha. What's cos alpha? Times 4 over 5. Am I right?
Yeah.
Okay, then minus tension. Minus tension is equal to resultant force. F is resultant force, which is Ma. And what's Ma? 3 Ma.
Mass of that's 3 Ma.
3 Ma. So that's a perfect equation we use. Every other thing you've gotten what you need. It says show that acceleration is 1 over 10g.
So how do I get M?
How do you get one?
M.
We cancel out. To show that acceleration is 1 over 10g, treat all as the same unit. So let me just write down the equation, then you just simplify. Treat all as the same unit like I explained to you. Are you ready for that? Go to the diagram. 3 mg is acting in the direction of motion, positive. Frictional force, negative. This tension, negative. That's tension 2, negative. Tension 1, positive. Weight, negative. So let's write the whole thing. Treating all as this as a unit.
Yeah.
We have three. It will be a long equation. 3mg sine alpha. What's sine alpha again?
3/5.
3/5 minus frictional force, which is mu r. Mu is 1/6. 1/6.
Times 3mg.
It's already 11. I will be releasing you soon. We'll continue with this some other time.
Yeah.
Let me just write it. Once you don't hear my voice again, you can go and rest. We will continue with this. It's an ongoing thing, and this is a very broad topic.
Yeah.
Okay, 1/6. That's for mu r. R is 3mg cos alpha times 3mg cos alpha is 4/5.
Yeah.
Then minus t2. Then t1 is positive plus t1. T1 is in the direction of motion. Are you getting me?
Yeah.
T1 is the direction of motion. Then minus mg. Minus mg equals, I've treated all of them as the same unit, so the total mass is 3mg plus 3m plus m. That's 4m. So this is 4m. 4m. Which is the total mass of this 3m and mass of this m, altogether 4m. So we just need to simplify that, because the question requires us to get to show that the acceleration is 1/10g. So we simplify that to see how we can get a equal to 1/10g. Okay, let's see. Oh, that's 4ma, by the way. 4ma, because the total mass is 4m. Remember, that's resultant force is what we express here. Resultant force. So that's actually 4ma. So let's see some things that will cancel out. I need to zoom out to reveal all. In this, T1 is the same thing as T2. It cancels out. So factorizing, we have mg, open the bracket, there's mg here, there's mg here, there's mg here. So mg, open the bracket, 3 times 3/5, that's 9/5, minus 1 times 3 times 4, that's 12/30, 12/30 minus 1, that gives us 4ma. M cancels out m. Now we have, well, so we're looking for the acceleration a. A will be equal to g times all these 9/5 minus 12/30 minus 1, which is 30/30. Well, let me still write 1, or divided by 4, or divided by 4. Making A the center formula. This whole place divided by 4. So this is going to give us A. We simplify the numerator. LCM is, hold on, let's write this properly. LCM for the numerator is 30. 30 divided by 5, 6 times 9, 54. Then 30 divided by 30, 1 times 12, 12. Then this one minus 30. Because this is like saying over 1. Before we divide by 4. So the upper one is 12 over 30 divided by 4, or 12 over 30 times 1 over 4. So this gives 4 here 1, 4 here 3, and 3 here 1, here 10. Of course, there's still a G here. There's a G here. So the final answer will be acceleration equal to, remember there's a G here by the way, equal to G over 10. This is the final answer here. The second part of the question says sketch the velocity time graph for the motion of B from the instant when A is released from rest to the instant just before B reaches the pulley. Explain your answer. Okay, we have seen that the acceleration is 1 over 10g and it's a constant acceleration. So the graph is going to look like this. It's going to be a constant acceleration. For an acceleration against time in meter per second squared, no, time in seconds, sorry. Time in second. Since the acceleration found is 1 over 10g, it's going to be in such a way that if we have g here, it has to pass through a point that we should have 10. So that the line will run like this. The line will not run like this. This is a graph of velocity against time, v in meter per second against time in seconds.
So now G has to be here and 10 has to be here, so that the gradient, which is rise over run, rise over run, rise over run, we actually produce 10 over G over 10. We are given that the gradient is G over 10, or 1 over 10 G. G over 10. G over 10. Here being 10 for time axis, here being G for speed axis. Okay. Remember, this is a constant slope of A equal to acceleration is equal to G over 10. From here, acceleration is equal to G over 10, or 1 over 10 G. So the rise should be G, the run should be 10, so that G over 10 gives the acceleration. Says, in reality, the string is not tight, or it's not light, it has its own weight. The string is not light. These are ways we model this light inextensible string. If the string is not light, it means the weight of the string has to be considered. The weight of the string has to be considered. If it has no weight, and center of mass of the string, where the resultant weight act should be considered. So its weight and center of mass should be considered. Its care were so that two men of masses 90 kg and 60 kg are hanging onto an helicopter which applies an upward force of 1,800 Newton on the first person A. Draw a free body diagram, calculate the acceleration of the men, and calculate the tensional force in the second man. Okay, this can be modeled like this. The first man being pulled by a force of 1,800 Newton, and then his own weight, because the mass of the man is 90 kg, so his own weight. The second man, his weight 600 Newton, because his weight is 60 kg. And of course, the weight acts downward, there's a tensional force acting upwards, another tensional force acting from here, and then the weight of A. All of these must be considered. The force pulling it upward, 1,800 Newton. The tensional force from A to be balanced by another tensional force from B. The weight of A itself, and of course the weight of B, to complete the free body diagram. We can apply the second law of motion, 1,800 Newton minus T1, which is going the opposite direction, minus 900, which is going the opposite direction, plus T2 going the same direction, minus 600. And that will give us the resultant force. Okay, and remember, the total mass of the two objects will be mass of A and mass of B, which is 90 plus 50. That's 1,000. Okay, that's basically what was done here. 180 minus T1 plus T2 minus 900 minus 600 equal to MA. And the total mass is 150. So 150A. And we're able to get A to be 2 meters per second squared and T2 to be 720 Newton. All right. Please don't forget to like, subscribe, and comment. Thank you so much.
Welcome to Like Learning School, your premier online education platform. At Like Learning School, we are dedicated to helping students and learners unlock their full potential, providing them with the foundation, support, and guidance they need for academic excellence. Our platform caters to two main target audiences. Firstly, we work with school children of all ages, offering academic follow-up and accountability partnerships. Our seasoned tutors provide personalized attention to ensure students stay on track and reach their goals. Secondly, we support students and learners who are preparing for internal, external, entrance, or professional examinations. We offer comprehensive and well-structured support to help them achieve outstanding performance in their exams. Our robust virtual courses are designed to keep students engaged and motivated. With interactive videos showcasing our teaching sessions, students actively participate in the learning process, making education enjoyable and effective. But that's not all. We believe in personalized education. Our students have access to personalized tutorial sessions, whether online, physical, or hybrid, tailored to their unique learning needs. Join us at Like Learning School and experience a transformative education journey. Visit our website at www.likelearningschool.com or contact us at +234 808 509 5144 to learn more and get started today.